there's a big problem for a incumbent big player to make a big change like that. And then there's also maybe the economic reasons. You know, Google is making billions and billions of dollars from those search. So if you have a problem, then maybe its cost is bigger. Now what this means, I think, is it might be an opportunity for a new search company now. Because they don't have 1,000 engineers to worry about, they don't have revenue to worry about, and they can be more resolute in embracing a new paradigm and to achieve a higher performance. And that's what band overtaking means. So that's what the innovator's dilemma is all about. Yes.
So one of my friends is a fellow named Anthony Goldblum. Do you know of Kaggle?
Yeah, Kaggle, yes.
There's like a website that manages machine learning competition.
Data competition and all that.
Yeah, yeah. So I was talking with Anthony and asking, he runs that, and I was talking with Anthony and asking him, like, what are people using? What do they use to win the competitions? And he says it divides into two groups. The what are called structured problems, where the data fits into something like a spreadsheet. You know, you got rows and columns and features already out and stuff like that. People use classic function approximation stuff, mostly XGBA, gradient boosting, you know, boosted tree kind of thing. And for the ones where they're unstructured, like text problems, you know, where you just got a big pile of stuff and you need to extract sentiment from it or something like that, they use neural nets for text and image and things like that.
Right, and that's a common knowledge today, where now my naive understanding is if it's text, if it's anything that features are easier to, it's already so naturally spelled out. The advantage of neural net over classic GBDT, gradient boosting, decision tree, or other algorithms, or even simple logistic regression algorithms, the advantage is very small. And now for the unstructured data where features are less obvious, like image or speech or video, then the advantage become more pronounced, because it's much harder to extract features by human brains out of those objects. And one interesting thing, let me finish this sentence, associated with it is the first fields that neural net made the biggest impact are the more sensory fields. Is essentially where we see, where we hear, and that has been, okay, it's not my phone, I hope. Oh, maybe it's just this. All right. Yeah. So, and I have a later slide get to it, is where it's actually changing the I/O, the interaction, the kind of the machine or human machine interactions in a more fundamental way, and that will in turn change a lot of other things. But it is what I learned as well. It's in those information where we made a big difference, and that's related to Google. The difference is small, but I heard there is certain advantage. But just because of all the other reasons, it's more difficult for a bigger incumbent, powerful company to make such change. So maybe it's an opportunity for band overtaking. I don't know if I'm mischaracterizing or slightly.
I mean, I work in ad rather than search, so I can't comment on the search. But I would say that Google has been putting a big focus on machine learning. In the past couple of years, has specifically set up classes to train engineers in machine learning. So I think we're doing pretty well.
That's good. Yeah. So well, certainly, the Jeff King is doing it. So, yeah.
So you have a new problem you solve, and solve the algorithm, you want to figure out can you solve it. How do you know how many
Actually, I couldn't hear very clearly. Can you?
So you're trying to apply this technology to new problems.
Yeah.
It sounds like when you have millions of examples, then you're more likely to train. But let's say you have another problem where you write an algorithm to solve it, or you think about using neural networks to come up with code. How do you make a decision about how many examples do you need before neural networks? What's the minimum number of examples? your framework.
Right.
for your design.
I think it depends on the complexity of the model and the class of the problem. And it's different case by case. And there are certainly people who are expert in each field. For example, I was talking to someone who's doing translation, and he told me for a reasonable translation system to work, he needs over 10 million sentence pairs to train a translate machine. Now that's and he said Google has the most right now, has 30 to 40 million pairs or something. So for you to build a good translator, the model is not the most difficult. In fact, the people sort of know what the model is. Really, the competition is who can get the most sentence pairs. And now you can go, how they do it is you can go to every website and to find every multi-language website and try to get those pairs. You get to every book that's ever been translated. But books, they said it's actually hard because those translators don't translate sentence by sentence. They kind of just they're creative in their translations, and there are other ways, you know. But generally, I think for different problems, it's case by case.
You mentioned that this new processing works best on sensory processing.
Yeah.
I would point out that there are many species on this planet that are much more intelligent than humans at sensory processing.
Oh, for sure.
This is an example. Going way back, a Frenchman came up with the idea that intelligence is one-dimensional, which is pure nonsense. It is multi-dimensional. He came up with the IQ test, and then Stanford produced a fancier version, still pure nonsense. And we're still living with that idea that intelligence is one-dimensional. It is not. You mentioned Google. They're sort of a spin-off from my lab. I created a search engine in 1961 that worked quite well, but it somehow never became popular. It was called Route, and it lets you pick up stories that used some Boolean combination of keywords. That worked. And the statistical method, of course, works better. But we could have been using that for years. It never got to market.
You know what? Maybe we hold off the questions for the time being. FS speakers have finished the talk.
Sure.
Thank you.
All right. So yeah. So as I mentioned, you know, the algorithms are becoming less important, and for a company like ours, we actually are creating data groups who are, you know, even we are a relatively small company, but we have a particular group whose sole purpose is to acquire data and acquire the data to feed our machine and find various ways, whether we buy them, we exchange them, we you know, find some ways to crawl them and process them. So data acquisition and data labeling becomes much more important. And now we have to worry about, you know, because we need a lot of training data. Training data, you need to have answers. And how do you find those answers? So we actually create apps and whose main purpose is to allow us to hire people to label the outcome of things. So for example, we create an app that allow people to make free phone calls, free international phone calls. And how they can do that is they accumulate credit, and either by watching an ad or help us answering questions. And by them answering various questions, then we got those labeled data back and allow us to train our machine. So there is an economy, a data economy being established, how you can buy and trade and acquire data at a certain cost.
How do you verify the data input is correct?
So then you have to design systems like, essentially we have to have every question randomly assigned to multiple people, and having some voting mechanism, and have a sampling and with experts checking and trying various sources. So it's actually a pretty sophisticated system just to dealing with acquiring and labeling data. And then the computing infrastructure becomes key as well. And in fact, I think after ARM, this is another huge challenge for Intel. In this new, ARM kind of completely changed the client computing infrastructure, but x86 still owns the data center. But now with this, the data center will be reshaped as well from the bottom up, from the chip all the way up. And what will be the new computing platform? There are various startups created who are seeing now NVIDIA as the only horse in the race. Everybody is using GPU, and they are very expensive. We have to pay a lot of money. Like in our little company, we have to pay like $1 million to NVIDIA to buy their chips in order to do our little app. But Google has their TPU, and other startups that started to creating AI chips, essentially simpler chips to do these matrix multiplication more efficiently. In fact, GPU, as of today, is not the best platform for doing matrix multiplication, because doing graphics, it requires more floating point precisions than AI or neural network needs. What I heard is that you only need 8 bits precision for neural nets. That means you can, using the same number of transistors to build more powerful AI chips than a GPU could do, because that's spending the energy and cycles on the precision that's not required. So there's certainly a new alternative computing platform that could happen. Now there will be algorithm people might lose their jobs, and neural net people are in high demand. In fact, they command a very high salary right now. Yes.
Oh, I'm sorry, we're not supposed to ask, but
Okay.
Continue.
All right.
the brain.
Maybe we
the
should let the
IBM's
speaker finish first.
IBM's brain chip. How does that compare with all of that?
I'm actually not familiar with IBM brain chip. Yeah. Okay, so I don't know if anyone knows, but we can't wait till the
It's
end.
called True North,
Okay,
the chip name.
is that a new chip or is that?
Came out last year, they're still in development.
Okay,
It's a
Supposed to
synaptic
be
computing architecture as
how
opposed
it
to
came out of the brain
Maybe so, I don't
project.
know.
it's a synaptic computing architecture as opposed to a von Neumann.
okay. I'll learn more offline. Okay, so now this is one we touched on, whereas the neural net is certainly making breakthrough in the sensory fields. And that relates to another interesting thought in terms of a human-machine interface. Over the last 30 years, if you go back to 50 years, you have those punch cards and things that I haven't used. And then when I was starting touching computers, it's a keyboard with command line. Right? So, and that's the keyboard era. And then you go into the mouse era, where you have the graphic user interface. And you have the whole programming paradigm created, how you create windows, menus, dialog bars, and so on, as the interaction between man and machine. And then you have the Steve Jobs iPhones, and that leads us to a thumb era where you don't need a mouse or keyboard; you just use your fingers. It's a new finger where you interacting with the machine. So now, could voice and vision be the new interface? Meaning, and that's why there's so much interest surrounding the Echo, Alexa, Google Home, and various voice-based computing platforms. Now that doesn't replace everything, because certainly there's a bandwidth, different bandwidth, in communication when you're doing voice comparing to you can look at the screen. But there are certainly many scenarios where you don't necessarily need a screen to let the intelligence between machine and human interact. So whether there could be a post-screen era from the thumb era to just a voice era where a new computing and programming paradigm might need to be created. New programs can be more easily developed on top of this platform.
I think an example is taking the Watson and connecting it to massive amounts of data on human medical history.
Right.
3 universities now are working on that project. Right?
Certainly, there are
databases.
There can be new connections being made and new interface being created, and so now we are only starting to thinking through this, and we think AI can certainly gradually impact one industry after the other. And I'll give one example there. So there are a few things listed, but I'll give one example. That's the one I'm directly working on right now, which is a mobile internet era. Actually, I'll give one example after two slides. Just a couple more. Actually, these two. Maybe I'll talk a little bit about this. So, and what we have found is that because of neural net is very strong with supervised learning. So when you have a lot of training data with inputs and outputs, it invariably can outperform humans because it can get very close to the best human could do, and it doesn't make mistakes, and it doesn't get tired, and it can do things much more faster. So we think as we look at those industries, one simple rule of which jobs are the first one to go, for better or for worse, is those repetitive jobs. Meaning those jobs where we have a lot of inputs-output pairs that can be collected. And any kind of jobs, even if those are white-collar jobs, that can be replaced by a machine pretty soon. So that could be a scary thought in terms of creating social issues just by job replacement. And then the more deeper question is one that I try not to ponder too much, which is as the machine become more powerful, especially we are living in a time of peace right now in the world, relatively. Now, thankfully, and now if that changes. What role will machine be playing in a human conflict, and that will lower the bar of a lot of control we can put in place to keep the machine in check. So there are certainly scary thoughts. I'm sure there are plenty of novels and movies that can be written and played, but we are more focused narrowly on the era of harmonious coexistence between man and robot, and that is happening as we see today. I bought the Echo, that's helping my wife a lot when she feels bored in the kitchen. You can talk to it. You can set. Really the key use case today is actually, how many of people here have Echo in your home? Okay, so the only thing we do are like play music, news, and set alarms. But still, it's pretty useful, and we actually have a robotics division created in our company. Now we have not only we build some speech interactions, we're building kind of robotic arms that can do various things in a kitchen to help you, and it's not inconceivable. You can certainly have cooking machines, and you can have various other tools that you can build with the robotics. Now the concept of consciousness and all those things becomes deeper and certainly more troublesome. Now let me go into the specific thing I have been working on. So And that's a tiny application of a machine learning algorithm. But I think the impact is actually quite big. And this is in the area of information dissemination or information distribution across the internet. And the internet actually went through a few different stages. In the early days, as I mentioned, you have the publishers of information and you have the consumers of information. And internet certainly democratized it. It allows it easier for anyone to publish. And then search engine came along. It became the portal for everyone to access this ocean of information, and it organized it in the best way possible. But it does require one thing. It does require that you know what you're looking for. So it requires a search term. So you have to know I'm looking for Caltech. Then I find everything I know about Caltech. And then social media comes along, and the mobile comes along. And in the mobile world, social media actually becomes a much bigger portal to the information than a search engine is. And there could be many reasons. And one reason we think is because with mobile devices, our interactions becomes much more fragmented. Average person turn on his or her phone over 100 times a day. And most of those just for a short period of time. And when you're working in such a high rate of interruptions, you become dumber and you don't know what you're looking for. You just turn on the phone to see what it tells you. So that's why you search much less. That's one of the reasons probably. You search much less on a mobile phone than on a PC, because on a PC you're sitting there, you're doing things, and you try to you know what you're looking for. So with social, the assumptions is it sort of have the information pushed to you, and how it decides what to push is through your social graph, through the people who are connected to you, and the information they publish and the information they like. Maybe you will like too. So, and that's actually a pretty good assumption, and that works a lot. But we think we're entering maybe a fourth stage, where the machine actually knows you better than your friends and better than yourself. So we're entering a period where the information will be delivered to you without you entering a search term, and without your friends have viewed it. But because of the data that we have about you, that we might know what you are looking for at the moment. So that's really the app we're working on. It's called the News Republic. It's actually a company we acquired last year, but we have changed the back end to be entirely AI driven.